7-3, more on parallelograms. So this is, as I'll mention later on, is pretty much going to be a continuation of what we just learned in 7-2, but just kind of the converses of everything. So as you look down the list of the learning targets for today, these should look fairly familiar. I know a quadrilateral is a parallelogram if its opposite sides are equal, if its opposite angles are equal. I know a quadrilateral is a parallelogram if two opposite sides are both parallel and equal, and I know a quadrilateral is a parallelogram if its diagonals bisect each other. And so again, if you look at these learning targets, these hopefully should look familiar, because before we were saying if it was a parallelogram, then it had opposite sides that are equal. Now this is just we're flipping the hypothesis and the conclusion around and saying if I know that there's opposite sides are equal, then I know that it is a parallelogram. And so again, as I mentioned earlier, this is pretty much the same exact thing, except we're just flipping the hypothesis and the conclusion around. So our first theorem that I'd like you to write down is a quadrilateral is a parallelogram if its opposite angles are equal. And so if I know that angle M is equal to angle O, and I know that angle L is equal to angle N, then I would be able to conclude that it is a parallelogram. And I would be able to then prove that, again, what I mean by proving that it's a parallelogram, remember the definition of parallelogram is just the fact that it has two sets of parallel sides, obviously opposite from each other. So saying that LO is parallel to MN and ON is parallel to LM. So every single time that I'm proving that it's a parallelogram, I would be able to create a proof based on the fact, knowing that it has opposite angles, that then it would be a parallelogram in that case right there. And we'll explore some of these situations a little bit later. Some of it might be also in the homework as well. Second one is a quadrilateral is a parallelogram if two opposite sides are both parallel and equal. Again, coming off of the same exact stuff as before, we would be able to prove that if I know that if I have one set of parallel sides, AB is parallel to DC, then, and I know that AB is equal to DC, then I'd be able to then prove that the other set of sides would be parallel as well. A quadrilateral is a parallelogram if its diagonals bisect each other. So if I connect the points from either vertices, that not saying that all these sides are equal to each other, it's just I have an equal side on the left and an equal side on the right, and I have an equal side on the top left, and I have an equal side on the bottom right. The next theorem that we have, which is actually the first learning target that we had before, is a quadrilateral is a parallelogram if its opposite sides are equal. That one again goes back to our work with 7-2, which said that if I knew that was a parallelogram, then I know its sides are equal. Now we're going to prove that basically if I know that its opposite sides are equal, then I would know that it's a parallelogram. So in this case right here, so if you want to write this theorem down, we are going to prove it right now with these following steps. So again, I know that it's a quadrilateral, meaning that it has four sides, and I know that Ji is equal to GH, and Gj is equal to Hi, meaning the opposite sides of them are equal. I would like to then prove that ABCD is exactly a parallelogram. Now with that said, what we're actually going to be proving is the fact that, again, the definition of parallelogram states that it has two sets of parallel sides, meaning that I would like to then eventually prove that JG is parallel to IH and JI is parallel to GH. But of course, let's start with our givens. And so as we go through, we have exactly what was stated prior, which we know would be our givens. Now as we go along, what I did was I had G and I basically cut in half, or at least the parallelogram cut in half by drawing that line there. Now taking a look at it, I know that this side is equal to this side, and I know that this side is equal to that side. What do I know about GI and GI in reference to basically both of those triangles? I should know that it's equal to itself because of the reflexive property. So then I should be able to state that the two triangles that I just cut in half, GHI and IJG, are then congruent to each other because of the side-side-side theorem. Once I've proven that basically I have congruent sides here, I would then be able to say that angle 1 is equal to angle 3 and angle 2 is equal to angle 4 because of the fact that basically because they were congruent. Now I'm proving that any piece of them are equal to each other. That would be corresponding parts of congruent triangles are equal. With that said, hopefully now you're starting to see the idea where basically, okay, I have angle 1 here and I have angle 3 here. Well, if I want to be able to prove that it's a parallelogram, meaning that JI is parallel to GH, I would know that 1 and 3 look like they are alternate interior angles inside of my parallel lines. And so I would then be able to quote based off of 2 and 4 and 1 and 3 that I have parallel lines because of exactly that. I have alternate interior angles. So 1 and 3 would then be proving that JI is parallel to GH, and 2 and 4, as you can see if you kind of turn your head, look at it 90 degrees, where 2 and 4 are up and down, you would be able to state that then those also are alternate interior angles because of the same reason. Now once I know that I have two sets of parallel sides, I would then be able to say that it is a parallelogram because basically of the definition of parallelogram, which as I've kept repeated a million times, we have proved that both those two sets are parallel, therefore we can conclude that it actually is a parallelogram if I know that I have equal sides, equal opposite sides. Last but not least, we have a rectangle is a quadrilateral in which all angles are equal. So again, making sure you write this down. This is based off of, again, the definition of rectangle, which states that all angles in our rectangle are equal, or all the angles are 90 degrees is kind of the technical definition of it. And so what I'm going to leave you with is I have a figure here. So we went through the previous proof, and so now I'm going to leave you with a rectangle here, knowing the fact that if I basically draw the diagonals out, I know that B to the center and D to the center are equal to each other, and A to the center and C to the center, those two are equal to each other as well. I would know that all of these are equal to each other. Why would I then be able to conclude that basically ABCD is a rectangle down on the bottom here? So I'm going to start with basically the idea that ABCD is a parallelogram, and I'm going to go through the list and basically prove that it is a rectangle. Now again, so as you start writing this down on your piece of paper and you start trying to think about the reasons why, I really haven't given any givens except for the fact of this here where I know that basically, again, what would I call BD, what would I call AC? Those would be diagonals. And what do these symbols show about those diagonals? And what can I use to then prove to why ABCD is a parallelogram? So I want you to think back to those theorems that we just discussed prior in this video. So as you go through, try to just work through it, and we will go through this in class tomorrow, but I'd like to see you at least put initial effort into it as you go through. So please make sure you have this ready for class tomorrow, and we will see you then.